In this video, we're going to be detecting uptrends and downtrends in the closing price of a given asset by automating the process of labeling higher highs and higher lows, which we can then use to label whether the graph is currently in an uptrend or a downtrend. So as you can see here, the animation which will produce flashes green when the algorithm thinks it's in an uptrend and red when it's in a downtrend. I've currently got it set to the lowest possible setting, so it will enter a downtrend when we have one lower low and one lower high, and an uptrend when we have one higher high and one higher low. A script of this kind is going to be useful as a filter to filter some other indicator that you've got that works best when we're trending in a particular direction. And thanks to the power of Python, we can automate that process and we don't have to sit and manually stare at the charts. So I'll pull up the notebook here and we'll get going. The first thing that you'll need to do here is get yourself some candlestick data. So I'm using the Python Binance module here in order to grab some K lines for ETH USDT. And I'm grabbing 6 months of 1 hour candles, but the methodology we're using will work with any data source. You can use equities, FX, anything which can be turned into open, high, low, close candles will work just fine. After we grab our open, high, low, close candles here, all I'm doing is trimming down this data frame. So if we look on the Binance documentation here, we have a bunch of other information like volume, the number of trades. I don't really need that, so I'm just trimming all that information out. We're making sure that the open, high, low, close are represented as a numeric type rather than a string, so we convert to float. And I'm also calculating the average true range here, which is a technical indicator that gives you an idea of how much a given asset moves, how volatile it is. This will become an important parameter later on, as we'll need to define what constitutes a peak in the graph and what constitutes a trough. So we need some measure of how much it moves regularly on a daily basis, and that way we can tell Python what constitutes an extreme move. I'm also taking the rolling average here of the average true range. That's just so it doesn't change too rapidly, as I'm also using the average true range to define the range of the y-axis, so that it always tracks the stock that we're looking at. So that's all our data processing, just regular open, high, low, close candles, and we've got an average true range. That's all we really need. You should have something of this sort. Now once you've got that, we can plot that using Matplotlib. I've got a bunch of imports here that we're going to be using later on. So if something doesn't work when you try this out, it's probably one of these imports that you need. But the very first thing we could do is just plot out the price data here. So I'm creating a new data frame, which is just the first 500 points, so it's easier to see. Create a regular plt.subplot, so we're using Matplotlib for this. We plot the price using ax.plot. We set the color equal to gray, the line width equal to 2, the alpha or transparency equal to 0.5, and the Z order equal to 5. This Z order here is important when you're drawing multiple plots on top of each other, as the higher the Z order, the closer to the screen it will appear. So if it has a low Z order, then it's going to be covered up by other plots that you plot on later. Okay, that's not very interesting, that's just a price plot. But the next thing that we'll want to do is smooth everything out. If you try and find turning points for this gray line here, so for the actual price line, you're going to get hundreds and hundreds of maxima and minima. And when it comes to technical analysis, we don't really care that much about the individual little spikes here. We're more interested in the overall trend. Say there's a peak here, a trough here, a peak here, a trough here, which constitute higher highs and higher lows. That's the kind of thing we're interested in. not so much the movements on a single bar. And the function which does this smoothing for us is a Savitzky-Golay filter. So I'll pull up the Wikipedia for it here. So as you can see in the animation here, what it's doing is it's plotting a point, and then it's finding the polynomial which fits best through those past few points, plotting that as the smoothed version of the line, then continuing to the next point, etc., etc. And what it's excellent at, and you'll see this if you read the rest of this article here, is it's very good at getting rid of spiky noise like we have with this price here, but retaining the overall trend of the data, which is what we're interested in as far as uptrends and downtrends go. So it's just one function that you import from SciPy, this savgol_filter here, pass in your data that you want to smooth out. There are some tuning parameters here. You can mess around with these, see which ones work for you. I've used 49 and 5, that seems to work well. And then we can plot that on top of our price here. So same as before, except we're just using a color blue. Now, after we've got our smoothed line here, the next thing we'll want to do is to detect our extrema. So the maxima and the minima, which again is helpfully provided by SciPy. So we'll look at the finished product here, and then I'll show you how I did it. So each red point here is a maxima that's being detected, and every green point is a minima on this smooth line that we've created using the Savitzky-Golay filter. How you detect them is just this find peaks function here. So all of this stuff is just the same as above. What we've done is I've grabbed the last value of the average true range from this DF2 here, so from this cutout of our data, I've grabbed the last average true range. That's just because the first few values of the ATR are going to be NaN, so you want a non-NaN value. And after that, I'll just use the find peaks function on our smooth closed data. The distance here represents how close the maxima and minima can be to each other. So a higher version of distance will make the minima have to be further and further away. This can be helpful if the function is detecting too many minima or maxima. You can crank up this distance here and it'll force them to be further away. The width equally here tries to get rid of really spiky maxima or minima. I've just set that to 3. And then the prominence again is a measure of how far the maxima and minima has to extend before it's considered a maxima or a minima, and I've just set that to the ATR, which we got up here. That's for the peaks. So there's this function called find peaks, and to find the troughs, all you have to do is multiply the price by -1. So what that would do on a graph is it would reflect it upon the x-axis here, and the peaks would become troughs and the troughs would become peaks. I'm using it with exactly the same settings as I looked for the peaks here. And what's actually returned in this variable is the index of the peak. So if I print this out just to show you here, so print peaks IDX, it prints out the index at the time at which there's a peak. So this one is going to be 170, so this is the 170th bar of our data here. This one's the 205th, etc., etc. To plot them, you have to remember that these are indexes, and so you have to index into the smooth price here at this particular index using eloc. I've changed up the plot settings here as these are markers. We don't really want them to be joined together with lines. So to do that, you set line style equal to none. The color I've set to red. Marker is just going to be a dot, and the marker size equal to 10. The Z order here I've set to be higher than the Z order of the previous plots, just to make sure that it actually appears on top of the line, as that's going to look a bit nicer. So we've got our highs and our lows, we've plotted them on the graph, What we now need to do is to detect higher highs and higher lows, one after the other. And then if we hit a certain number of higher highs and higher lows, we want to change the background color of the graph to reflect that we're in an uptrend or potentially a downtrend. So how do we do that? Well, all of this code here is exactly the same, so don't worry about that. And the way I implemented it is I set a variable here called upRunLength. So that's going to be the length of the upwards run that we're currently on right now. So if we're using this as a filter for our trade, we don't really care about historical uptrends. We only care about whether we're in an uptrend right now or not. So the current uptrend I'm going to set to 0 because we haven't detected an uptrend yet. And I'll set upRun equals to true. That way we can do while upRun here. So this while loop's going to start, and what it's going to do is it's essentially going to check whether the high that's closest to the right hand side here is higher than the high that comes before it. So it's basically just checking, is this greater than this? And it's also doing the same for the lows. So if the most recent low is greater than the low that came before it. That's essentially all this long, complicated if statement does here. We're just indexing into the smoothed prices here on successive peaks. So this is -1 minus the length of the run, and this is -2 minus the length of the run. So it's always comparing, say, this one with this one, and then this one with this one, and then this one, if there was one before it, it would compare to that as well. And if that's all true, then we're in an uptrend right now. So we're going to increase up run length here by 1, and then repeat the whole process. So we go back up, and on the second run, we're going to compare this one to this one, and this one to this one. Now that's true again, so we're going to increase the length of the run again. But you'll notice we don't have any previous highs to compare to. And so what happens there is this if statement here breaks us out of this up run. It's basically just checking that we have enough maxima or minima to look at to determine our uptrend. And it also protects us from getting index out of range errors over here. And so we'll break out, and the final value of up run length is going to be 2. So we've detected a run of length 2, which means that this high is greater than this high, which is greater than this one, and the same for these 3 low values here. Then what I'm doing is I'm saying if the run length is greater than 0, so if we have at least one set of higher highs and higher lows, then set the background color here to be green. These are just RGB values here between 0 and 1. So this is the red value, the green value, the blue value, and this is the alpha or the transparency. And if we don't have a run, well, set the color to white here. So what I can do is I can index a bit further here into df2. And if I run that over here, we can see that we're no longer in an uptrend as defined by this logic here, as we have a lower low here. So if you compare this high to this high, we have a higher high, but we don't have a higher low, and so the run length is going to be equal to 0. It'll just exit straight away. And therefore we set our face color, which is the background color here, to be white. Of course, you can play with this logic here. I know a lot of you would still consider this to be in an uptrend if you're just looking at it from a technical point of view. This is some kind of retest of this area here. But from a strict higher highs, higher lows point of view, we're no longer in an uptrend. So that's how that works. And you can do the exact same thing here to detect lower lows and lower highs for downtrends. Basically just copy and paste this section, change this variable to be down run instead of up run, and then set a elif in here. So elif down run length is greater than 0, etc., etc. That's all you'd have to do to detect the down lengths here. I just didn't include it here because it's a bit overwhelming in terms of the amount of code. And so this is all you need in terms of integrating this into your trading strategies or your backtesting libraries, as you can detect whether we're in an uptrend or a downtrend using whatever data is currently available to you. And as long as you're conscious to not include any data from the future here, you won't have any look-ahead bias or any of that kind of thing. But we can go further here and turn this into that nice animation that I showed you at the beginning of the video. The syntax is largely the same. So you'll notice I've got this RC params here. That just makes sure if the animation's really long and it takes up a lot of space, that it'll still actually be embedded in our Jupyter Notebook. I've also got this bars in frame variable here. So what this is doing is saying how many bars are going to be visible on the graph as the price goes by. And that's also going to define how far back our function is going to look for maxima and minima. So you want to adjust this as per your preference. The other main difference here is how you plot things. So you create the plot as normal with ax.plot, but the main difference is you don't actually put the data in here yet. So we just say price, comma, so we only want the first returned object from this function here. And we do the same for the rest of them, so price underscore smoothed, comma, equals ax.plot. But we don't include any of the data. And what we can do is, during the animation, we can set this data for this line to be whatever we need it to be. If you plot the data on every single frame of the animation, they all get plotted on top of each other and it doesn't look very nice. So I'd strongly recommend doing it this way. So we have our 4 different plots here. I'm also setting the Y limit and the X limit here. So this is the limit for the X axis and the Y axis. The Y axis is going to get changed actually during the animate function here. So we don't need to worry about that too much, but just set the X limit to however many bars that you want to actually view. And then the main area where all the magic occurs is during this animate function here. Broadly speaking, it's exactly the same as the version that we had up here, so as this one that can detect the different runs. So you'll notice a lot of similarities. So I'm grabbing df2, which is a subsection of df. The reason I'm doing this is to make sure that I'm avoiding look-ahead bias. So I'm grabbing the bars only up until the current day. So whenever I calculate any of my indicators in the following section here, I'm not risking looking ahead into the future, which would be pretty bad. It is more inefficient to do it this way. So if you're confident that you can avoid look-ahead bias, then you can compute all of this stuff beforehand out of this function. I'm including a few extra frames here. You can see in this frames behind here and what's happening inside this index here. The reason for that is so that the Savitzky-Golay filter here won't try and constantly refit the data at the beginning of the animation. So you can see it's all very curving around over here at the end, but we don't want that at the beginning here because that would be quite distracting. So I'm including a few extra frames in here to make sure that the filter doesn't go haywire, but we can trim those off after we've calculated our filter here. And then what comes next is much the same as before here. So instead of doing price.plot or ax.plot, plt.plot, etc., etc., I'm instead doing price.setData. And I'm setting the data equal to this value here. So this is just a list of numbers from 0 to the length of df2 here. And df2 is just 300 bars, as we saw earlier. So we set the data inside this tuple here. We set the X and the Y values obviously just being the close. We do the same for the smooth price, and we calculate the average true range, again, the same as we did before. What we then have to do, which is slightly different, is we have to change the Y limit here. So the price is going to move up and down, obviously, as the market continues its journey rightwards. But we want to make sure that the animation is nice and zoomed in. So what I'm doing is I'm setting the Y limits equal to the minimum price on the smooth curve minus 10 times the average true range, and then I'm setting the maximum Y value equal to the max of the smooth values plus 10 times the average true range value. The reason why I'm using the smooth curve as opposed to the regular price curve is that the regular price is going to be a lot more spiky. So when you actually render out the animation, it's going to look very janky and jumpy. So I'm using the close smooth here. And that's again the reason why we smoothed out the average true range right up at the top of this notebook. It's so that this Y limit, because we're changing it on every single frame, doesn't go all haywire on us. Peaks and troughs, exactly the same as before, nothing's really changed there. I've added the down run, like I said how to do before. It's literally just a copy and paste of this, but with the variables named slightly differently. We set our peaks and troughs values like we did for the price. So again, it's set data. We're not plotting, we're just changing the data in those lines that we plotted earlier. We have our if-else statement here. So if we have an uptrend, then set it to green. If not, then red. And if nothing else, then set it to white. So we're in a neutral territory. Finally, you'll want to return all of the lines that you've drawn. So we've got price, price smooth, peaks, and troughs. That's all we're drawing on this graph. And with that, you can pass this function here. So this animate function, you can call it whatever you want, but I'm passing it in here to this func animation function, which you can import from Matplotlib. If we have a look at what we did earlier. So yes, we've got matplotlib.animation import func animation. The interval here is the time between each frame in milliseconds. So I've gone for about 50 frames per second here. Blit equals true optimizes the rendering of the animation, so it just speeds things up. You have to pass your fig in here, so make sure you do that. And the frames here, I just set this value so that we wouldn't get any index out of range errors, as I'm using this value of frame here. So if we go up here, frame, I'm using that to select our df2 here. So every time the frame gets moved up by one, we drop the first element of df2 and add the next element. So we're always continuously moving this window throughout df. And once you've done all that, you can display this now as a HTML5 video. This is from IPython, this HTML, and this display.display. Again, it's in our imports from earlier. And this should more than likely work on your Jupyter Notebook installation. So you can see here, it's all working. You can leave this playing, it'll just continuously replay. If you want to save it down to disk, you can do this. So it's exactly the same as writing any other text file, essentially. So we open up a HTML file in write mode, and we write video.data, where video is equal to this. And what that means is you can pull this out here, so this video.html, and you can embed this in a website or something else. It's just a nice, convenient format to play things in. And obviously very easy to embed into Jupyter Notebooks. If you can't get this to play on your notebook, you may have to set the graphics backend. So all the way up here, I did this Matplotlib inline, this magic function here. Have a try at that and see if it works for you. Or you may have to change the backend to Qt or some other kind. So I hope you enjoyed this video on how to detect uptrends and downtrends by automating technical analysis, that you learned a lot and that it'll help you in your trading journey.